Right, welcome to this first lecture on engineering maths 3. Right, as the first thing, we're looking at series solutions of ordinary linear differential equations, first order and second order, I think. Right, the basic idea here is, or it uses the same method as the method of undetermined coefficients. And the main assumption is that we assume that our solution y of x, assume that our y of x can be written as a series, say a0 plus a1 x minus some constant, say c, plus a2 x minus c squared, plus on and on. So we're assuming that our solution is a Taylor series expansion to it. Right, that's the whole idea. So that in a more compact form, this is normally written as this. Then you have your ak x minus c to the power k. Right, but for now, maybe for the interest of those who have not done looked at power series, I may have to take an aside and look at an aside, that is, define what a power series is. Right, a power series is a series that's given in the form sum from k equal to 0 up to infinity of ak x minus c to the power k. This thing is given by a0 plus a1 x minus c plus your a2 x minus c all squared plus on and on. Or if you can call this one here, say star, or I can have this as sum from k equal to 0 up to infinity of my ak x to the k, where this is equal to a0 plus a1x plus a2x squared plus on and on. Maybe this one we'll call it double star. Right, and x is the variable and the ak's are the coefficients that must be determined both in star and double star. So the whole idea is to find out, is to determine what these ak's are. Right, so right, the series, of course, would converge to the series will converge to x is equal to c and x is equal to 0 for star and double star respectively. Right, maybe as a way of an example, find the values of x for which the series, this series here, find the values of x for which the series n equal to 0 up to infinity of x to the n converges. Right, or simply put, that I could say, find the values of x, of find the interval and radius of convergence. This can be asked maybe alternatively, as one can say, find the radius and interval of convergence for this series here. Right, so how you solve that, or how you go about that solution, you have to define a sequence an. You have to define a sequence an given by x to the power n, and then another one, of course, an plus 1 will be given by x to the power n plus 1, and using the ratio test. So using the ratio. We calculate the limit as n goes to infinity of an plus 1 over an. Right. Calculate this limit n. Right. In this case, our limit as n goes to infinity will be what? X to the n plus 1 over x to the n. And this is just the absolute of n. And then this converges if what? This will converge if the absolute value is less than 1. If the absolute value of our L, or if L here is less than 1 in absolute value, then you know that our series will converge. So obviously minus 1 less than x less than 1. Right. This would be the interval. But then we have to determine whether these n values are included or excluded in our interval. That is, I can take now the case when, say, when x is equal to minus 1, what do I get? I get the series, the sum from k equal to 0 up to infinity of minus 1 to the power k. And this series here is divergent. It does not converge to any unique value. Hence, we say it is divergent. And so is this series here. If I take the case when x is equal to 1 to the power k, this is also divergent. So my interval of convergence, my interval is minus 1 less than x less than 1, strictly less than 1, not less than or equal to there. And my radius of convergence, of course, is going to be half 1 minus 1, which is equal to 1. So the series k equal to 0 up to infinity of x to the n will converge if and only if the values of x are strictly less than 1. Otherwise, it will diverge. Right. Right. And there's a theorem there which says that given any power series that's given in this form, sum from k equal to 1 up to infinity of your ak x minus c to the power k. There are three possibilities, right? That is, possibility number 1 is that the series can converge when x is equal to c, because when x is equal to c, right, when x is equal to c, right, when x is equal to c, all these terms up to infinity, they go to 0, and thus the series will only converge to a naught. That's the only non-zero term. Or in the case of the other series, this will converge to a naught if x is equal to 0. And in any case, this series here, or my star here, the series that I wrote as star initially, is a special case of double star. That is the case when c is 0. Right. That's just a special case of that. Or you can have this possibility here that the series will converge for all values of x. right? The series will converge for all values of x. That's another possibility. Like normally, or an example of that that I can think of top of my head is the Maclaurin series for your sine, which is given by x to the power 2k plus 1 over 2k plus 1 factorial for k equal to 0 up to infinity. This series here will converge for all values of x equal to 0 up to infinity. This series will converge. Or the third possibility is that there may be a positive number r such that the series will converge if what? If the absolute value of x minus c is less than r and diverges otherwise. That is if the absolute of x minus c is greater than r, then this will diverge. So the number r there is called the what? Is called the radius of convergence. The number r called the radius of convergence. And then the numbers c minus r less than x and c plus r. In fact, c minus r and c plus r is the interval of convergence. It's the interval of convergence. Right, and the ratio test, the ratio test, as I had shown in my previous example, it says suppose that you have a series sum from k equal to 0 up to infinity of ak x minus c to the k, or just ak, which is given by that, is a series of non-zero terms, and that sorry, in fact this one here, let me just use this, of ak, right, is a series of non-zero terms. Then the series converges if what? If you calculate the limit as n goes to infinity of your an plus 1 over an. Right, if L is less than 1, that is in absolute value, then the series converges. Absolutely. The series will converge absolutely. Then if L is greater than 1, then the series diverges. Then if L equals to 1, then the ratio test fails, because at this point you can't say that the series is convergent or divergent. In that case, you would have to use other tests, maybe the integral test and the comparison test, or any other test which is not the series, which is not the ratio test, right? Maybe let's look at an example once again. It says determine the radius of convergence for the power series. Example 2. Example 2 says determine the radius of convergence for this series, sum from n equal to 1 up to infinity of x plus 1 to the power n over n to the 2 to the n. So, solution. You define your an to be x plus 1 to the n over n by 2 to the n, and an plus 1 to be equal to what? X plus 1 to the n plus 1 over n plus 1 by 2 to the n plus 1. Then we calculate the limit here. The limit as n goes to infinity of what? X plus 1 to the n plus 1 over n plus 1 by 2 to the n plus 1 times, dividing by this term here is the same as multiplying by n by 2 to the n over x plus 1 to the n. And clearly this term cancels with all that. In fact, I'm just left with this term, and then 2 to the n cancels that, and I'm left with the 2 there, and then this one goes, so that I'm left with what? The limit as n goes to infinity of what? Of n over n plus 1 by the absolute of x plus 1. Right, and this limit here is n goes to 1, sorry, to infinity goes to 1. Right, that limit goes to 1, and then we are left with what? With x plus 1, and for convergence we demand that this be less than 1. Right, and then if I open this up, I'm left with minus 1 is less than x plus 1 less than 1, and therefore this gives me minus 2 less than x less than 0. No. Something's wrong here. No. There's an error here. There's a 2. There's a 2 at the bottom here. So that here I've got a 2 by n plus 1. Right. This thing becomes wrong. This becomes 1 over 2 by x plus 1 less than 1. So that this becomes what? The absolute of x plus 1 is less than 2. So I get minus 2 less than x plus 1 less than 2. So that this becomes minus 3 less than x less than 1. Right. So when x is equal to 3, I get what? When x is equal to 3, this is from n equal to 0 up to infinity. We go back to our problem and substitute minus 3 here. Then we get what? Minus 3 plus 1, I get minus 2 to the power n over n by 2 to the n. And clearly this will reduce to what? Sum from n equal to 0 to infinity of minus 1 to the power n over n. And this converges by what? This series converges by the alternating series test. right? This will converge by the alternating series test, and then we test which this has to be minus. And when x is equal to 1, I end up with sum from n equal to 0 up to infinity of 2 to the n over n by 2 to the n, which gives me n equal to 0. Yeah, I think I've been making this mistake. This has to start from n equal to 1, because at n equal to 0 is undefined. This is n equal to 1, not 0. This becomes 1 over n. And this diverges. This is nothing but the harmonic series. So my interval of convergence becomes what? Minus 3 less than or equal x less than 1. And you notice that the radius of convergence is 2. Because 1 minus 3, 4. And then take half of that is 2. Or if you look at this limit here, especially at this point, it gives you an indication of what the radius is going to be. Right.